Good day to all. Welcome to today's webinar. People are still joining in, so we will wait a couple of moments more, and then we'll start. Okay, I think we can go. Good day again. I would like to welcome you in my name and also in my colleague's name. So Gregor Pipan and Jan Cunja will be hosting you today, and we both hope that you will enjoy our company. Let me first share some technical information about this webinar. So as always, our webinars are recorded, and the recording is shared with the audience later on. Just a second, Jan, can you please mute your microphone? Thank you. And you can post questions during the webinar. You have a special section in the webinar dashboard for that purpose, and we will try to answer those questions. We'll see if we have time at the end of the webinar. Otherwise, we guarantee that the questions will be answered via email, and we will share them with all of you. So we have a lot of new first-time visitors at our webinar, so I would like to take the opportunity to share some information about our company. So we're a software company, and we specialize in the digitalization of the built environment since the very beginning. We have more than 30 years of experience in this field, developing this specialized software for civil engineers. And today, we'll be sharing with you some of our experience in the field of channel and river engineering design. Our company is present all around the globe. So we have offices in Slovenia, Germany, Czech Republic, Serbia, but we have a quite wide network of partners and resellers. So we are present on all continents since 1990. We're also involved in activities of the international organization Building Smart. So we're a member of Building Smart, and we provide certifications and educations for civil engineers. And being part of Building Smart is it also means that we strongly advocate the open BIM approach and standardized IFC data exchange, so that our solutions can be used in sync with other applications that engineers need to achieve certain tasks. Our portfolio covers almost all aspects of civil engineering. So we have solutions for roads design, railway design, and river engineering. And today we'll focus on this last software, AQUATERRA, that is specialized for designing channel and river engineering works. And it's a professional software. It has it seamlessly integrates these specialized CAD and BIM design tools with powerful hydraulic calculation engines such as Mike-Flat or HEC-RAS. And its primarily application include flood protection design. So AQUATERRA kind of assists in creating robust flood control measures. Then it is also used for irrigation system design. It supports efficient irrigation planning. It can be used for other similar projects in water for water-related engineering design, but it can also be used for torrent and landslide control. It software actually helps mitigate the impact of torrents and landslides. So in summary, AQUATERRA combines design capabilities of the software with hydraulic calculations to provide comprehensive solutions for water-related projects. Now I would like to go straight to technical presentation. So I would like to give word to my colleague Jan Cunja, who is actually a product manager at CGS Labs, and he's responsible for the development of the software AQUATERRA, which you will see in action today. And Jan is specialized in water science and environmental engineering. So I'm sure you'll be in most capable hands. So please, Jan, take over. Jan, we can't hear you, so I think your mic is muted.
So am I sharing the right screen now?
Yeah, nice, everything's good, okay. Yes.
Good. Okay, so welcome from my side as well. I will show you our software for flood protection design, AQUATERRA, as Gregor said, and we will go first through the fields of use, and then we will see how AQUATERRA was used in a real-life project to avoid floods. Then we will go quickly through the basic workflow in AQUATERRA, and we will see how to design flood protection measures and see also other AQUATERRA features. So fields of use are many, and as Gregor already said, primarily AQUATERRA is used for river and channel design, for flood protection design, and also torrents and landslides control and river restoration. It can also be used to design irrigation systems on open channels and earthworks, so you're able to calculate the quantities by sections and create a summary table for the whole area and draw a mass hole curve like you see here in this picture. So the most important field of AQUATERRA use is probably designing flood protection measures. And this is something that I have to show you. So here is Ljubljana, a part of Ljubljana, capital city of Slovenia, in the year 2014. And the reason I'm showing you this video is that 1 year ago, in 2023, we also had serious flooding events in the whole country of Slovenia. However, there was no floods in the area that you see in the video. And even though the amount of rainfall was similar to the one from the year 2014 that you see here, and the reason that there was no floods was that the Slovenian company Izvor designed a plan for flood protection of the Gradaščica River basin, which runs through this part of Ljubljana that was flooded in 2014. And this project was funded by European Union Cohesion Fund. And company Izvor prepared the project documentation for the construction of the flood control facilities that were implemented in time, which means before 2023, where this area was also under the great rainfall amounts. Yeah, there was also a lot of rainfall in this area, but this area wasn't flooded in 2023 because of this project, because of these regulations that Izvor designed and that were now then implemented. And AQUATERRA played an important role in this matter since AQUATERRA was used to design this project. Our companies were shared their project documentation with us. So here you can see layout and one of the cross sections. And they also used MIC software from DHI to make hydraulic analysis. So I have to say right now that AQUATERRA also can export and import files between the AQUATERRA and MIC. So in AQUATERRA, you can design your geometry and then import it to MIC, do your hydraulic analysis, and then return results back to AQUATERRA. And more than this, it is also possible to use HEC-RAS, which we will use today and show you how these things are done. There are more pictures from this success story that I was just telling you about. And if you scan the QR code, you can learn more about this project. More is written on our web page. So now my idea is that we go through some basic AQUATERRA workflow very fast, and then I will show you how to design flood protection measures in AQUATERRA. Let me just say that if you are just starting with AQUATERRA and if you need more detailed step-by-step workflow to learn the basics, you can watch our online AQUATERRA training course. So I will show you where you can find it. So yes, here on this web page, we will give you these links after, but here you will find all the videos for doing basic AQUATERRA tasks. The whole workflow, there are 7 lessons. Each lesson has PDF instructions and DVG file that you can use and do things on your own, step by step, following these instructions in the video and in PDFs. So these instructions, basic training is free, and you can watch it whenever you want. But today we will go through this workflow much faster. So without further ado, I would like to start with this. So here we have AQUATERRA layout. Actually, these are just this is just data from geodetic survey, and we also have some bathymetry here. If we change the view, you can see that some of this data has its own elevation and some do not. We will use all this data to create a digital terrain model. But first, I want to add some other points that we got from LEADER data to this model. I have already prepared those points and I can input them here, input points from file, where you can input different point files. And if you want, you can also make your own specialized file. So you can import any points you want. Okay, so here I have my leader file. And as you can see, this data is here for easting, northing, and elevation. We have also point type and so on. When I click OK, these points are imported here. And now I will just edit these attributes because I don't need all this attribute data. These are actually labels and elevations. I will just close this so everything will work a bit faster. And now I can make a terrain from this. We will create digital terrain model, and here to create surface, you can use points and break lines, and you can also add boundary. You can insert from file and so on. With the plus sign, you add all these entities. Then you can select either you want a presentation with triangles or with contours, or both, like this. And you can also edit contours, so we get more dense contours and so on. So we will just use triangles, and actually I will also close this because we don't need to see it right now. Okay, so these are our elevations. You know what? I will also turn off these points because they're slowing a model a bit. Okay, so here we have our situation. We have created our terrain, and now we want to start with the AQUATERRA alignment. You have different methods. You can create tangent polygon or best fit alignment using some data from the set of points, or two polylines or one polyline. But here I will use polyline to alignment tool that will transform this polyline, which is actually my my river alignment. And wait, let's do this again. Yeah, so it's important to have alignment manager open, which will tell you which alignments you have inside your model. And if you don't have a river alignment, you can add it with adding like new axis. So here we will create this alignment again, and longitudinal axis is created. So the important thing is that you have this alignment active, and then you can create an alignment. Okay, now we will drape this alignment, which is actually still on the here at the elevation 0. We want it to be draped to our surface. So we have triangles, triangular surface, but it's hidden now, and I will just drape it like this. So you see this green line indicates that the alignment is draped to the surface. Now we can add also some sample lines. We will here can set the spacing and maybe starting station and ending station if you want. And then when you click OK, these sample lines are created. Now, if we look from the isometric view, again, I have sample lines here, but not here, and I can drape them easily to the surface. So you can see now these lines will be then used to create cross-section views. Okay, we can create a profile view, and it's nothing to it, just select it, the location in your drawing, and then you can draw a profile like this. So here I want to go a bit lower, and you can use parameters to help you set the right elevations. So let's say from here I want to draw a slope like this, and then another slope like on this. And now we have created actually, yeah, what we have here. This is a riverbed from the existing state. This is the green line that was draped to the surface, represented in profile view. And it's at the current riverbed. And now we want to add another profile line that will be our new riverbed. And this, of course, will be a bit deeper because we want, this will be one of the regulations to prevent flooding now. So then we can draw a cross-section view like this. And as you see here, you have these cross-section views. These are terrain lines. And this point here is the point where this newly designed profile was drawn. Okay. So this is actually the state before any regulations. And I just want to show you a HEC-RAS model on which I was working on to show you what was the previous state. So here, if you go to RAS mapper, we can see. So I have worked on this project. I have inserted the cross sections from AQUATERRA. I will actually show you how this is done. But first, I just want to show you the existing state in HEC-RAS, and then we will show you how to import these cross sections in later in a few minutes. So here are the imported cross sections from the AQUATERRA, and we can see here also I have this alignment and sample lines. Everything was transferred to HEC-RAS model. And then we made some hydraulic analysis. And here we can see the results. So if I click play, you can see the water fills the channel and then spills over and affects these buildings here. So these buildings here are flooded. And now the idea is to go back to AQUATERRA and prevent this from happening. So we will go back to AQUATERRA, and here we will design a new riverbed. So I will use some elements that we have in AQUATERRA, some typical elements that you can use in designing a channel. And here in AQUATERRA, we have included these elements like channel dikes, embankments, channel linings, embankment linings, and so on, and some other things. So if I select channel, for example, I will get these elements. I can select the channel bed width and depth, and then the slope, and so on. And when I click OK, this channel will be attached to the point where I draw our profile of the new riverbed. So this is one thing, and then we can go to construct a dike, for example, and like we can do this. For example, let's try, we can also edit elements. Here you can see how, and I will just make it a bit deeper so we can see how this dike functions. let's say we have this dike, and you can add the dike here, and then the dike is constructed. So this is one option to add the dike, and then you can also add the embankments and so on. Embankments are useful when the channel is under the terrain. Well, to make this faster, to show you, I have prepared the macro. Macros can be easily saved. So if you create something here, you can just say save macro, click on the cross section, and then it will be saved, which I have done. And now here I have on the list of macros this macro that I want. I want it to go to all sections, and when I click OK, this actually appears on all cross sections. And here you can see I have a channel, I have some embankments here and here, and also dikes. Yeah, they're very small here, like this one. Okay, and when I have this, I can create from these elements, I can create a new terrain line, and this terrain line will be then transferred to HEC-RAS. So one more thing that we can do before we create the terrain line is we can define projection points. Projection points are actually, you can define any point on any element, and you can then transfer it to layout as a line, because these points in each section will be connected in a line. But here you have some predefined intersection points like left and right bank, and left levee and right levee, and these points can be set here already in AQUATERRA and then transferred to HEC-RAS or Mike. So here I have put left bank on the left dike, and again these procedures are all shown in a video that we have in basic training course. So if you don't follow, you can always go on our website and check it there. I will just add some bank points. I'm adding a left bank again because here I have an embankment, not the dike. And here I have on the right, I have put a point on the right embankment, and I will also put it on the right dike. So here, when I say right bank and click it and select the dike, it will tell me element with label air bank already exists in the working area on the embankment. So I can say draw element only in profiles where it does not exist, and it will be drawn on other profiles as well. And now you can see that we have created left and right bank points on all the sections. This actually makes things much faster. So, okay, now we have these projection points, and we can assemble the terrain line, which means that we will select all the elements we need. So we need, when we select it, we need left and right bank and left and right dike. Here we have, and channel, so channel, left dike, left embankment, right embankment, and HAMAS actually we don't need. So here we can name this terrain, and we can make it current. This means that when we want to work on our profile cross sections, this will be the terrain that we will be working on. So for example, when I select export to cross sections, here I can select new terrain, and now I can export it to the CRO file. So I will export it to existing state CRO file. So this I will replace the, okay. So now I have exported this cross section. Actually, I made a mistake. I wanted to put this into design. So yes, because this is the designed terrain. We have designed it, and now we will want to save it in this file. Actually, I have already done this before, so this is why I already have these files. They want to replace it. It's not important for me. But yeah, now we have created a cross sections file. And why this is important? Because if we want to export this to HEC-RAS, we need CRO file, which is the file we just created, and RCA file. And yeah, so we need these three files. First, we need to save the terrain. We need to save projection points that are our left and right bank. I have already done this, and we need to save sample lines here. So sample lines are actually the information of these lines here. And then when we have all these three files, we can export it to HEC-RAS. Now, I know this exporting to three files and then using this command can be a bit time consuming, but we are just working on this new function that will do everything in one function altogether. So it will be faster, but now you can also do it pretty fast. And here you can select the output file. We will save it to our HEC-RAS project to here, AQUATERRA exported files to existing state. So river existing state will be our geometry. River designed will be our geometry, which I have already done. So because I have used this on my project, I will not save it now, but this is how you create geometry. And now I will go to HEC-RAS model of the designed state. So here we have actually everything inside, and I would import the geometry using the file import geometry data and HEC-RAS format. Here I can select our geometry that we have actually it is this one. Yeah, so this is the geometry that will be imported, and then I have already done this, so it's the geometry is here and in the form of sample lines and this longitudinal line, and also we have cross sections views here. This is how we export the model from AQUATERRA to HEC-RAS. And now we have made some regulations here. We made it this channel deeper and a bit wider, but also I want to add a dike to this model. So the idea is that dike would be here between the river channel and between the residential area. So it will protect these houses from flooding events. And I have here, if you can see this yellow line will be the axis of our dike. Now, maybe these labels bother you. We can make them smaller with the scale, and it's quite easy to make them smaller. Now it's better. So here I will use this again as before when we made the river alignment. I will use this polyline to construct the dike. I want just to save this file just in case. Now we can add another new axis, and it will be an axis named dike, or here I already have it on the list, and I will just click on it, and now I will use this polyline to alignment tool. I will select the dike, longitudinal axis was created, and now we will go straight to adding sample lines. We will make them 5 meters wide on each side, and everything else is okay. So now I have these sample lines, and I can drape them to the surface. So this is it, and now I will create a profile view. And here in profile view, we will add the highest elevation of the dike with the draw profile. So it's actually the same as before. We will make it a bit like this, so it follows with the terrain. And this is our, let's say, the upper part of our dike that is constructed along this axis. And now we draw a cross-section view of this. We have the point here, and we want to draw the dike. And again, I have already saved the macro for the dike, and I can select OK, and this will draw my dike. Okay, so this is it. We will again assemble a terrain line. We just select all the elements that we have drawn. We type a name. And click OK. Now this terrain is here. Now the question is how to transfer this to HEC-RAS, and it's you will see it's pretty easy. As before, we need to export the files, but first, because we don't need these parts of the terrain, we will use the trim function, which is not Autodesk function, but AQUATERRA function. And it works a bit differently because it only works on cross sections. But this means if I use trim on one cross section, it will also work on all the others. So now I have selected the cutting edge, and now I'm selecting the terrain, which is now, you see, trimmed, but it's trimmed on all the cross sections. I will show you in a moment. So here I will just select again this line, so enter, and also this. Now, if I select similar, we can see that this terrain is trimmed on all the cross sections. Now we can save this terrain to a file. I have already done. I have put it into a dike CRO file. Yeah, we can replace it. We use this terrain dike that was constructed just now. We can replace it. And then we actually don't need to save projection points like before. We just need to, again, save sample lines here. And again, I will use the name dike. Yeah, sample lines. So these are these sample lines here. Okay, now we have extracted, we have exported these two files, and now we can go back to HEC-RAS export. There's one more important thing. When I go to save RCA file, we need to press enter here. And this is it. Okay, so here I can deselect IL file, and I will just select the right one. So dike CRO file and dike RCA file. And now we can output this to our here. So to this, to get the geometry of the dike, we can put it here. So like this. And now conversion succeeded. Okay, so this is it. Now, how to get this dike into HEC-RAS? I will show you. So we can open a new project. We can name it dike, and let's put it here, maybe in a create folder. Okay, so let's do it again. I'm not sure what was wrong. So okay, and now when we have a project, we just add import geometry data. We will use our exported data here. So dike, and we have to select the right units. And now we have here the cross sections. That's not, it's okay, it's okay. So these are cross sections. And then we also need, we have cross sections and the longitudinal alignment with sample lines. And if we go, if we save this geometry, now we can, so I will show you how to put dike into your terrain model now. Here, if you, here we have the, cross sections. So here we have our dike, and we can export this layer to GeoTIFF. This will create a GeoTIFF from the cross-section data. and we can save it here like this. We put in the raster cell, and like this we have created terrain. Actually, yeah, here we have to first assign a projection file, not project file, but projection file. I have it here. So this is for Slovenia. And now we can input our terrain. As you can see, this is our terrain of the dike. And this we can connect with other terrains, like we can go to create HEC-RAS terrain. We can use the terrain, and we can add also our dike to this terrain. So it's important that dike is on top of the list. And now we will create a new terrain, which will consist from these two terrains. So the basic terrain was all this, and now here we have also our dike. Okay, so this is just to show you how this is done. I have already prepared this project, so I will show you how it looks like in the end when everything is set as it should be. And here we go. So before, if you can remember, we had this situation where the residential area was flooded. Yes, so we can see the animation again. And now what we have done in AQUATERRA was a few things. We have first deepened the riverbed and then also widened it. And we have added a dike, which was constructed using the same AQUATERRA functionality as for the river channel. And we have put it here. So now from this flooded situation, we can go to a new terrain that we have built. So we have made a river a bit wider and deeper, and we have added this dike as we have shown before. And so let's see how things work now. So if you start the animation, we can see that water comes out of the channel, but is then stopped by this dike. So this was a way that you can use AQUATERRA geometry in HEC-RAS model and then do the hydraulic calculations. But you can also import the results back. So if you go import from HEC-RAS, you can select the exported file, exported text file, which I have here. And these are your results. And now you can save this to some water surface file. We will add this. And yeah, you can just create a new water surface file, of course, if you don't have it here. But I already had it because I've done this before. And now this is converted. And we can apply these results to cross sections like this. So it's important that you select the proper alignment here, and let's do this again. So here you can see the water surface level represented in this AQUATERRA model. If you can notice here, this line goes to the new designed terrain because we have selected that it's current, and this is what we want here. So then you can also transfer the water surface levels to profile view, and this is this completes the cycle so you have export and import from HEC-RAS and to HEC-RAS, and you can also export to mic and export export cross sections and axis to mic, and then import back from mic. Before I show you some shortly how this is done in mic on some pre-recorded mic session, I wanted to show you also how easy it is to create a 3D model. In AQUATERRA, for example, let's look at this dike. We can go to cross sections and use planimetry. So it's actually, we will hatch our dike, and I will use inner point method, but you can also use between two polylines, which means you will select the upper polyline and the polyline below, but here we can select inner polyline. We will use TCS elements and terrain, and I select OK. And now I will just click here and inside, let's do it again. I have to select again the proper alignment. Here is important, and now you see that this dike is hatched, and this surface here will represent the amount of material that is needed. So you can very easily do the quantity takeoff table. Here we will calculate by cross section. We will select where the value will be shown. We can save it to file, but now I won't. And then we can insert the summary of quantities also in our drawing like this. And now when I'm satisfied, I click OK. And as you can see now, this is the amounts of fill for this dike. And here are the amounts also organized in a table. And in the end, you have a summation of these numbers, these values. Okay, this was very fast. You can of course create your own materials and so on. But now I want to show you one more thing, and it is a creation of 3D model. We will create this 3D dike, and I will go back to our terrain function and just turn these triangles on so we can see what will happen here. And I will also change the view to realistic, like this. And now we go to utility, we select draw 3D model, and here we want to align it on this axis. And another thing that I will comment a bit later is property set. Let's select CGS property set. Now we select OK, and this dike is created. So, so this is 3D model of the dike, and it's that easy also to make model of the river channel. So with the click of the button, you can create 3D model. So the property set that we have selected here is actually can be managed in Property Manager. Here you can add different properties to these 3D solids. So here is just the table. You can organize it. You can add your own. You can add different values. So then if you go to property set editor, you can select one of these 3D solids, and then you can see the properties these solids have. So it has a name of the axis, an end station, a start station, a volume of this 3D, and the material of this 3D model. And these are all data for your BIM model that you need for your BIM model. So, I mean, not all of them, but these things you need for it. And you can, of course, add your own property sets. You can add 3 property sets to one model at once. So each of these elements can have 3 property sets. Here we have also property set filter, with which you can easily find properties that you're looking for. Now everything is selected, but I can also use, I don't know, volume and station, and I select one of these, and then this the element with this property set will be found. We also have clash analysis. You can export these 3D models to IFC format, which is standardized. Then it's possible also to add some Google Maps picture. Actually, you can only insert raster or also elevation data, which is of course not as precise as LIDAR data, but for some like idea of the project, it can also be useful maybe. So you can import elevation data from Google Maps, but now we will also only import the raster, and from this elevation data you can create surface, but we already have a surface, so I will just click import just so you can see the picture, if we can show it. Yes, like this. Okay, so and here is as you can see, here are the This is, for example, our axis. Yeah. So it is also possible to export this model to Google Earth. And yeah, I think this is everything I wanted to show you today. One more thing. So as I said, the model can be also, the hydraulic modeling can also be done in Mike DHI software. And of course, AQUATERRA is an add-on that runs on Autodesk, AutoCAD, and Civil, but also on BricsCAD, as you see here. And here is another example where we have used this data from AQUATERRA to export it to Mike. Here you can see the alignment in Mike 11, and then we have also imported it to Mike Hydro, which is now called differently, I think. And here, but it's the same thing. So here we have cross-section geometry data, and we can also show the results and see it in Mike Viewer like this. Okay, so from my side, this is everything. As I said, if you want, you can go to our CGS Labs webpage for more information, but I think Gregor will also have some of these useful links now. So Gregor, I leave it to you.
Okay, thank you, Jan. Just let me share my screen with you. Okay, so we're a bit short with time, so I'll try to wrap this up as fast as possible, not to keep you too long. Jan had a really nice technical presentation, very in-depth. So if you would like to explore this part of mic compatibility or mic usage with mic hydraulic computation models, then you can go to our basic training. It has a special section there, and you can go there step by step. As Jan mentioned, just visit our webpage. What I would like to let you know is that our software can be tested. You can apply for a trial version. The trial is usually 14 days, and it is fully functional, so you don't have any functional limitations. You just go to our webpage, you go to the CGS Labs AQUATERRA product part of the page, and you will see there you can apply for the trial, and then we'll contact you. And what is important that during this trial period, you have access to 24/7 CGS Labs knowledge base, where you have extensive tutorials to use the software. And most important, you can always contact our technical support. So we have a really capable team of engineers that will help you when you're working with our software. Just go to our webpage, and you will see again link to all these knowledge base, technical support, and other things that you need during your trial. Then all our webinars are recorded. So this session that you now attended will be added to extensive list of webinars, which is also accessible through our web pages. You just go to our webpage, go to the very bottom of the page, you will see their link to webinars, and it will get you to this specialized platform, and you will see webinars divided into sections. We have actually webinars in multiple languages. For example, if you are from Germany or I don't know, Czech Republic or whatever, you can check if there's some localized webinar available for you. And you will see there are webinars really for all sorts of products that we feature. And here are some more important resources that we provide. So we have a blog that regularly features some technical information for our products. So you can apply for that, and you will get notified when we prepare a new post. And also our YouTube channel is very rich with content, so you can go there and explore it. I mentioned Go to Stage for the webinars, but most important, I suggest that you connect with us on LinkedIn, and then you will get instantly notified whenever we produce some new technical materials. So I hope that this webinar was what you expected, that it was well informative, and we thank you both with together with Jan for attending for this 60 minutes. We're 15 minutes overdue, I think. We will check if you posted some questions, and if you did, we will answer them in the follow-up email, which you will get also with the link to this recording. But if you have any other questions, don't hesitate to contact us. You have our contacts on our internet pages. You can also contact any of our partners or offices all around the world, and they will approach you with I think any solution that you might need related to what you have seen today, or any other software that we provide specialized for civil engineers. So thank you very much for your attendance, and hope to see you soon on one of our next webinars. Goodbye. Yeah.